Okay, so we're on to part 2 now of the Midland 76900 base station, like you can tell from this angle. So the big snag which has held us up, when we can zoom out, the big snag is the display. So you'll have seen on part 1 we got the 2 right hand bars out. So after a lot of research, you know, you put hours into this research, we discovered that there is an American firm, and what I've got to say here, this is nothing whatever to do with CB radio. This is to do with general electronics. What I don't want people to think they've got to do is to look for a display from Midland 76900 base station, because it isn't going to happen. The product's 40 odd years old. So you're just not, you know, it's like writing to Bush and asking them about the 1960s range of radios. Well, Bush isn't Bush anymore. Midland don't make anything, do they? They just buy stuff in. There's one batch and then it's off. So this is why at this time you've got the Precision series being made by Maxon for them, and this being made by Cybernet for them. So I thought I'd done the tune-up on this, but I hadn't. So it's Ferrite is the firm, an American firm, and I'm going to tell you it's an A562G. Obviously the G's for green. And you have to fit it upside down, so the decimal points are to the top, but this doesn't use the decimal points, so it doesn't matter. So it looks like it's the wrong way around, but it's absolutely spot on. Now I've done the power supply. That was the other hold up. I always have to order these individually. We don't have this these 2200 microfarads. We get 50 volt rating one, not because it needs it, but because it fits in the holes. So, you know, we'll measure the diameter with the calipers, and then we'll order something which is the right number of microfarads that actually is a snap-in type. It's kind of between a CAN electrolytic and a normal one. So there we go, that came from RS, it was a special order item. Then we've got the other capacitor, I think it's 100 microfarads. Got the squirky diagram from the trader service sheet. So it originally was 2200 at 35 volts, it's now 50 volts. And then we've got 100 at 25 volts, it's still 100 at 25 volts, but with an uprated temperature. So powered it up with the radio disconnected. So here's the power supply, and this wire is the output to that tag there. We disconnected it at this tag, because what I didn't want to know, when you've got an unknown set like this, and it may be immaculate, but because the case isn't immaculate with all that rust I showed you, I've given it a bit of a spray, it's obviously been stored in a dodgy position, hasn't it? A damp shed, back of a garage, certainly for probably 10, 15 or 20 years. So because of that, I want to be sure. Now that power supply, if the series pass transistor failed, which is the one on the heat sink and is a 2SD313, if that went short circuit, it would pass the entire output of the transformer and rectifier, and we'd end up with about 26 volts coming out, which of course will blow the radio up. So it's precautionary to disconnect the power supply from the actual radio, which we did. Well, the opposite in fact happened when I powered it up, and it only did 10 volts, probably a bit less than that. So with the preset there, there's an adjustment preset, I could vary it between about 5 volts and 10 volts. So obviously something wasn't right, and I felt that this transistor shown here was getting warm. So I thought, hang on a minute, this Zener diode here is probably leaky. So I took the Zener diode out, which is there, and it was indeed faulty. It wasn't short circuit, it wasn't open circuit, it was leaky. Of course, goes without saying, had I got any in stock? No, I hadn't. I had to order some for another hold up. So we're that way on with the layout. So it was that Zener diode. Oh, that's upside down as well. We want the one the right way up. It's that way on, isn't it? So there's the Zener diode. That's from underneath. So power supply then worked. We're going to carry on the tune-up using the bench power supply rather than the mains power supply. Then we just will check the power output with its own power supply. But I did set it for 13.8, and it should be exactly the same. But I need to monitor the current, and so to do that we'll be having the bench power supply on. So I give you these tips so you don't blow up a potentially valuable radio. Now, as I say, I paid about 200 quid for this in the state it was, and I'll be surprised if I get 200 quid for it when it gets shoved on eBay on Friday. But I need to recover what money I can, and if it gets 350 quid, well, it will have paid for the repair and a bit more, won't it? Paid something towards the postage. Right, so we will switch it on, and there we have it. I'm going to have to bring the front. Oh, we've got this meter to do. I'll do the tune-up. I might have to change all 3 lamps. I knew there was something. So, Cybernet standard mic. It's possible that new display could be brighter than the original. Right, there we go. So we'll start with the VCO. So we need to be on channel 40, and we need the multimeter, which has gone where? Hello, where are you, multimeter? Oh, it's up there. I've got a funeral to do shortly. Nobody I know, purely professional. And you know what, it's a warm day. I've got the air conditioning on in here, and I'm really not looking forward to putting a suit and a jacket and a tie on. Get that the right way round. And I've got to do some shopping for a lady in her 90s, and there isn't time for me to get changed. So by the time I come here, back here, I'll probably be walking around in my birthday suit for the rest of the day. Right. Not sure whether these are negative earth or whether it's... I can't think why it would be floating. So test point as usual. It is. It's fine. You can't see. You can see that, but you won't be able to because I haven't put picture in picture on. So as usual, just like doing a Harrier CB, it's exactly the same chassis, but you do get the extra coils on the base station. So you get the extra one like you would on the upper, like the York 863 Rotel 240, sometimes on the Harvard 420, sometimes on the Rotel 230. You get the extra coil there, and on the base stations you get the extra coil there. So we should have 4 volts on receive, very marginally high. You know, I don't think this set's ever been messed with, and usually these have been messed to death. Okay, so that'll do me. So we want 4 volts on transmit. Would help if I plug the test equipment in. Gollum transmitter with no load connected, although it is on low power. Right, let's try again. Go into transmit. I've not made any. Oh, I've done them before, haven't I? So, channel 40. We've got 3.46, so we could do that coming up a fraction using the red trimmer. Got 4 volts now, and we've still got 4 volts-ish on receive. So we'll pop it on channel 1. We should have somewhere between 1.8 and 2.4, 2.5. So we're bang on in the middle on receive, and on transmit we're banging on the middle. So that's fine. It's never been messed with, it's just drifted over 40 years. So I'll do the transmit, remembering to put the radio back on channel 20, and remembering to put it back on full power. So let's look at the clipboard. What did we have? It's so long since I did this. It was 4.6 plus 4. It's now 4 plus 4. So that's done. I'll tell you what, we'll put it on frequency. We can always come back to that later. Let's put the frequency counter up on the inset. .779.126. They do drop down with age, so if you're going to not be exactly, it's best to be very slightly high, which we are. So we'll do the transmit now. So what we've got, we had 4.1 through to 3.9, so it was absolutely bang on, to be honest. But we have to just verify that it's bang on. It's supposed to be within 0.1 between the top and bottom channels. We're looking for the centre of the peak. Well, I'm not showing you the right meter. So that's the first coil done on the 4 watt scale. Centre of the peak. It's not quite in the centre there, but it was at the peak. That was spot on already. So we want the blue trimming tool. So it's the usual procedure where we have to put these all 3 to full. And like I say a million times, never leave them at full. I've seen these left at full. Oh, we get more power. Yeah, but the PA is not designed to do it. It's designed to be on top of the job. That isn't moving. That is moving. I hope these aren't broken. Otherwise we'll be ordering from Knights. what I don't want to do is to break the plastic trimming tool. So what we're going to have to do is I'm going to have to find an Allen key to fit. You never ever adjust them with an Allen key. But I can do it with the power off just to make sure they're free. And you don't need me to explain why you don't do it with Allen key. No, we'll have to pause the video. I'll go and do all these jobs, come back in 2 hours, go in the organ workshop and get an Allen key. So as we rejoin hours later, the 2 of these are broken. So it was immaculate until I came up against this. So I've unsoldered one. Maybe possible to take it out and put it in the other way around. Will this be a part 2? Because I'm going to order some from Knights. If he's still got them. The trouble is, there's only 3 of these coils in a set, and on the odd occasion you do end up with a scrap cybernet set. That's one of the reasons they usually scrap, because they've already been destroyed. I've got an Allen key set here. Let's see if we can take it carefully out of the bottom. If it just cracks at the top, yeah, if it just cracks at the top, you can't pull it out, but you can from the bottom, if you get me. So it may be possible for me to put it in upside down. Let's put it that way up. Yeah, so somebody's had a go at tweaking it up in inverted commas with the wrong tools. So I'll just take this to the top. Then it will turn with the proper tool. Right, well, that's one of them done. Just in case it's important as to which way round these go. It's the ribbed side towards well, the bottom on in this position. And these are also fun to get in. What we need to do now is find the other one and unsolder that. So we've got the driver transistor there. So it's ribbed to the bottom on this one. See whether we can get this one out of the bottom. No. No, this one will have to be broken out. Now, what can I do? I'll have to put the video on pause while I see if I've got anything with still got a scrap set kicking around, or one which has been given me, or even one I bought. Oh my goodness, I'm so lucky. I've just looked on Knight's website and they've sold out. So I've got this illegal AM American set here. And it's made by GRE. It happens to have got these two purple coils in it, which have got perfect cores in them and are the right size, and I've been able to put one of them into there. So that was been a very nice set at one time, TRC 421A. So it's very sad that it's ended up in this country illegally, and of course it had to be chopped up. Right. So that's it, we can't get these anymore. So I've got one left in that realistic. Right, so we'll put that Allen key away. And what size was it? 2mm. Must remember to take them back to the organ workshop. I'll just make sure from this side that I haven't distorted the legs. Or whatever I've done, I can't get one of them in. Puffing about looking for cores. It's an hour gone. So you look at this as it was, rusty and knackered looking. Then we open it up and it's absolutely immaculate. And then it's holding this little secret, isn't it? That it's been ruined. So they've got it to do 3.944.1 before, before breaking the cores in more or less the right position. Just see which way around this goes. Got a set here which I can look at. Yeah, I said it was down. Rib side down. Well, it's time for tea, so if I can just get this in and the transmitter tuned up. Yeah. Right, I can't see any dry joints. I'll go with that repair with isopropyl alcohol once the thing's working. Right, power supply on, radio on. See whether we can tune up the transmitter. So we've got that one in the right position. So we'll start here. So we'll tune it down till we find the sweet spot. That was the sweet spot. We'll tune this one down till we find the sweet spot. Recheck that one. It's 4.5, sorry. 4.6. Just recheck the last of the pre-drivers. Right. Okay, so we tune the yellow one clockwise for 4.4 watts. And we tune the green one anti-clockwise until the manual says 3.8 watts, but we're allowed 4 watts, so 4 watts we'll set it to, not 3.8. Remember, they have to get set through customs, which can be individually spot tested by the customs people, and if they were over power the whole batch would be rejected. They're always set under power. Right, moment of truth. So, channel 20, 4 watts, just like it was before. Channel 40, 3.95 watts. Channel 1, 3.95. So, what we're going to do, when it's on its power supply, I don't mind that being 4.05, 4 and 4 when we get to that stage. Alright, let's pop it onto low power on channel 20. Oh, our current consumption is now 1.388. Now, you see the difference there? It was 1.5, so it was off tune. So it was doing the right power. There's no improvement really, because it was already doing the right power, but it was wrong. It was drawing 200 milliamps too wrong. So it's putting a strain on the transmitter for absolutely no reason. Right, low power. See whether this is going to set or whether we have to replace the preset. So right now it's doing 1 watt. So will it adjust? It's a little jittery. Waggle that one round. Try again. 400 milliwatts. Yes, it was 900 milliwatts before. So let's do the power meter. I just don't think I can show you this, because if I tilt it up, I'm gonna. Let's press transmit on high power. So it's showing 3 point something at the moment. I'll get the trimming tool in the right preset. Now I'm gonna have to kind of do it and then show you. So if I kind of, I don't know whether you can even see on that angle. So it's now reading 4. Which, at least on this radio, is a relative power meter, even if it only reads true into a dummy load. As I said many times before, all the new sets are pre-programmed to just shove the bar graph across. Even if you take half the transmitter parts out, it'll still say it's transmitting at so many watts. So what we'll do, we'll disconnect it from this test set and we'll go over to the other test set and we'll just check that deviation is right. What I want to do is to set this one to a particular position. I'll tell you what, we'll set it up on this test set first and then verify it whether it's right or wrong. As I said, the deviation meter function on this test set needs the capacitors changing, and it's not going to happen. So let's put the oscilloscope on. Let's look at what we thought we'd got. We'd got 3.8, which is far too high. Now I've adjusted that, so it's going to affect it. Wallow, it's now reading like 7. So we'll just pop that. I mean, that's at full, so yeah, it has been messed with, hasn't it? Wallow. That's a peak of 2.5. So we'll go over to the test set behind me and we'll just see whether that's correct or whether it's lying today. Right, other glasses. Wow. It's very slightly low. It's 2.2 peak. Wow. That's 2.5 peak. Right, we'll turn that test set off. This is when you discover your mic gain wasn't up or something stupid like that. So now plugged into the test gear. Signal generator. We'll just check if this radio is still on frequency 4 hours later. Oh, we're going to play that game, are we? We have to switch off external speakers, a switch somewhere. Okay, whatever I do, it causes feedback. 2779137. So just pop that down a fraction, but not that much. That'll do. Now we'll set the signal generator. Will do. So we're at 1 microvolt. I need to switch to the external speaker, which is there, and then we'll look at the oscilloscope and put enough volume on. Just try and make sure all these are at full. Apart from the swells. Do the detector, Just recap where I was with it. Was around, a deviation was around 5 plus kilos, ridiculous. So it's now 2.2 to 2.5. So it was 0.3, so it was already working well. Now, often the screwdriver experts don't mess with the receivers. We need to be on a 100 microvolt signal. What am I playing at? That was already spot on. So put the SINAD meter on, and we'll now drop the attenuator and we want about 4 dB to go down a scale. We've gained a little tiny bit there, so there's the coil we don't normally have. Spot on. There's the other coil we don't normally have. Put a bit more signal on. Funnily enough, a little tiny fraction there. So let's see what we've got now. There's really only the first one that there was any movement on. So for 12 dB, we've actually got 0.22. 10 dB, just under 0.2, but if I change scales there's an overlap, so we'll put it down as 0.2. For 20 dB, 0.63. Right, let's put 100 microvolts on the signal generator. If I tilt that up, you'll see that meter is very close to the 9. So we'll adjust that till it is the 9. There we go. And finally, the squelch. So 4, that's now at 100. So that's actually come right. It was wrong before, but it's come right. Done the meter lamp. 2 times ferrite cores, hex cores. Oh no, it was only 1, wasn't it? 1 ferrite core recovered and refitted. Okay, so squelch, which I still haven't looked at, it was exactly spot on. No argument over that before. Let's see where it is now. So it will be different. So squelch to full. Let's put the attenuator controls on. So I want it to open as 100 microvolts. So 3, 10, 30, 100. That's it, it's still right. So we'll now do the opposite. We'll park the signal generator at 0.35 microvolts and then switch it to standby. And then we're going to turn the squelch to threshold on the radio. And then we'll switch the signal generator back on. and discover that I could do a better job of setting threshold. Might help if there were knobs on the radio. There we go. It's 0.65. Okay. So that's it. So next thing, I have done the lamp. We'll put some glue on that because they're different size. And yep, that's it. We need to start putting the case together. I'll set the power. Well, before we do that, I'll put the front on it, and we'll set the power supply up. And the next test, we'll come back. We'll just check the transmit power on its internal power supply, and just make sure that's within legal limits. So unfortunately, time's run out, and I'm not going to do anything for a couple of days. So the best thing to do is to release what we've got, so you can see where we're getting with this. So just to recap, the radio is now finished. All the meters are lit, and the display's working. I need to put the case together, and first of all we'll need to just check that that power supply is running the radio properly, and that the power output is consistent with what I've got on the clipboard. So I'll say thanks for watching part 2 of this Midland 76900 restoration, and I think we were very lucky that we'd got that scrap AM set to recover one of those cores from. Thanks for watching.